Hi, and thanks for joining me in this discussion on IFR conditions. This video is one of many that I have at my YouTube channel that deals with IFR weather. In this video specifically, we're going to talk about the climatology of IFR weather. You probably know climatology deals with the long-term trends in weather. In this video, we're going to look at that long-term trends in ceilings, visibility, and then finally, we're going to look at a climatology of our local area. Local area would be eastern North Dakota, which means Grand Forks and also Fargo. First, low ceilings. Of course, to get low ceilings, you need a source of moisture and also some sort of lifting action to get the air to rise and cool. So wherever you find those two things, that's where you're going to find most low ceilings. Now, as far as moisture, it varies across the United States, but generally speaking, you have moisture conditions along the Gulf Coast and the East Coast of the United States, and as you move inland to the Intermountain West, it's drier. So that would mean that you would probably have more frequent clouds along the Gulf Coast, and also probably lower cloud bases. You remember from our discussion of the temperature dew point spread and how you can calculate cumulus cloud bases. Here's an example, just looking at average temperatures from Tampa all the way up to Laramie, Wyoming in the summertime. If the summertime temperatures were about the same, say like 86 degrees Fahrenheit, which is 30 degrees Celsius, the dew point does vary significantly. Down at Tampa, it's pretty high. It's usually in the 70s, and that would give you very low cloud bases on the order of about 2,000 feet. But as you move west, as the moisture decreases progressively, cloud bases, cumulus cloud bases would go up. And this just is to highlight the point that when you're flying VFR out in the western part of the United States, typically cloud bases are very high and you have very good VFR weather conditions. Other places where you find low ceilings, of course, when you're close to a body of water, so that would be coastal areas where you have lifting actions, such as in mountainous areas. And then also when weather systems move across the United States, they cause rising and sinking motions. That rising motion will produce clouds. And we're going to look at the kind of synoptic weather patterns, or the areas where you find low clouds with a weather system. So there are two areas with weather systems, with big low pressure systems that have warm and cold fronts. One area is called the area of overrunning. The other one is wraparound. Overrunning is typically found out ahead of the warm front. As the warm, moist air from the Gulf of Mexico, in this case, runs up over the warm front and over the colder air that's located, in this case, over Wisconsin and Michigan. Wraparound is found on the back side of the low. As the winds circulate around the low pressure system, they bring the moisture from out ahead of the warm front around the back side into the cold air. And typically this region is a region of low clouds and also clouds that don't really have a lot of vertical extent, meaning that they are pretty low. They stay low in the atmosphere and usually not a very thick layer of clouds there. This diagram shows the air-met Sierras for this storm system, and as you can expect, the IFR weather is out ahead of the warm front in the overrunning region, and on the backside of the low where you find wraparound moisture. This diagram shows regions of IFR, low IFR, and MVFR, so this is your flight categories, and it matches up very nicely with the air-met Sierra, and it does show actually through South Dakota that there is heavy snow and then lighter snow through Nebraska and off out towards Wyoming and western South Dakota. It shows very low IFR conditions across South Dakota, Nebraska, and southern Minnesota and central Wisconsin. And then here's the satellite image for the storm system.
it shows higher clouds out ahead of the warm front, and there may even be a little bit of convection. In other words, some thunderstorms, not necessarily thunderstorms, but just convective elements across Wisconsin, because you can see the very cold cloud top temperatures. You can see the circulation, the comma, and the head of the comma as moisture comes around the low pressure system to the backside. Notice also that the wraparound clouds are not as dark blue, which means that they are warmer temperatures. Also indicative here, you can see the cold front stretching, the clouds indicating the cold front stretching from Iowa through Kansas, Oklahoma, and then down into Texas. And immediately behind that cold front is south or southwesterly winds that are bringing in drier air into this low pressure system, all the way into Nebraska, where the center of the low is located.
So we went through low ceilings, low visibilities. Where do you typically find areas of low visibility? Well, fog can cause low visibility, and you can find fog in typically coastal areas because there's a lot of moisture there. Also mountainous areas because of the lifting action caused by the mountains. And then also in low-lying areas. Typically cold air drains into low-lying areas, and you have higher frequency of fog in those areas. The time of year varies depending upon local knowledge. I mean, it depends upon the location and the time of year. So it's best to kind of talk to the people in the local area to tell you when the IFR conditions, low visibility, occurs in your area. This is a map of the frequency of fog across the United States. Some places you can see highlighted in green and also kind of dark blue have a very high frequency of fog. And these are places that you should note and you should actually memorize. Is the Pacific Northwest. As a matter of fact, there's right at the mouth of the Columbia River between Washington and Oregon, there's a camp called Cape Disappointment, actually. And that was named by Lewis and Clark because it was so foggy and they were so disappointed when they got to the West Coast. So the Pacific Northwest has areas because of the moisture and also because of the mountains. Also, you can see along the Appalachian Mountains of the United States is an area of green and blue, and the very high frequency of fog there. That's caused by the, of course, the uplift with the Appalachian Mountains and also the moisture coming off of the East Coast, off of the Atlantic Ocean. So you can see the states like West Virginia, North Carolina, Tennessee, they call that area the Smoky Mountains because of the clouds and the low visibility. And then finally, up in New England, you can see that also has a very high frequency of fog. And we're talking about Maine to New Hampshire and also Massachusetts, Rhode Island, that area. And that area has fog because, once again, they're very close to a source of moisture, and also there are mountains over that area. There are other things that reduce visibility: haze and smoke, and also dust. Haze and smoke, of course, typically caused by combustion or industrialized areas. You'll also find haze a lot of times near coastal areas where you have industry, and then also low-lying areas. The time of year, well, typically you'll find the most haze and smoke reducing visibility are in the wintertime because that's when you have strong inversions. And those inversions set up in valleys or low-lying areas.
During the summertime, you'll find haze and smoke downwind of large areas where there are wildfires. So that would include California, Oregon, Nevada, also Montana. They tend to have wildfires. So the winds generally blow from the west to the east, and that's not always the case. Also, there have been a number of wildfires in Canada over the past several summers. And as a result, visibilities in the Midwest and eastern United States have been reduced because of that.
And then dust typically happens when you have very strong winds over the ground. Here in the central United States, that typically occurs early in the spring. If there's no snow cover, when you have very strong winds, it can lift those particles or the sand and dust off of the ground. So you'll see this in the fall, in the winter, and also in the spring. And also it can happen in the summertime with strong thunderstorms and the outflow that results from them. Here's a frequency of dust, and the purple and not purple, but the dark blue areas indicate the highest frequency of dust. Once again, you should remember this, that the dustiest places in the United States, the most dust storms that they have, occur over West Texas, and this is the Dust Bowl of the United States. Anywhere from Lubbock, Texas, across Amarillo, the Oklahoma Panhandle, and then through western Kansas, through places like Goodland and Liberal and Garden City. You can see that in eastern Colorado, those regions have very dusty conditions. North Dakota, you can see up there, does get a higher frequency, but not as much as the southwestern part or the southern plains of the United States. Okay, so let's switch to local climatology. What we're going to do now is look at Fargo and Grand Forks. The National Weather Service has been accumulating weather information over the years, and they've tabulated it, and this is what they have. So we're going to look at Grand Forks and Fargo. We're going to look at ceilings and visibilities, and then after that we're going to look at flight categories, meaning IFR, low IFR, VFR, so on and so forth. So first, here's Grand Forks with ceilings, and you can see a trend, and it looks like you have the highest frequency of very low IFR, IFR, and MVFR. In other words, the combination of all those into a bar graph. You'll see that it looks like October and November have the highest frequency of these conditions, at least added up. So in other words, it looks like the worst months to fly, if you're concerned about low ceilings, is November and December. But also, January, February, March are not that far behind. June, July, August are great months. If you want to fly here at UND, the best months are the summertime. Stick around for the summer and you can fly your tail off. Here's visibilities. No, this is ceiling for Fargo. And Fargo shows the same trend. November and December also has very low ceilings, high frequency of low ceilings. And June, July, and August are great. Here's your visibilities, and it shows a similar trend. You get into the winter months and you have low visibilities. And that is, looking at the highest frequency is probably December and January. Even February is really close in March. And as we saw before, May, June, July, August, great months for flying. But everything changes, seems to change right at November, and then it changes back in April. Fargo has the same trend. January, December, worst months, followed by February, March. And then it changes dramatically in April, and then changes back in October, moving into November. Here's the flight category. So this includes ceiling and visibility. And you can see that the worst month in Grand Forks, lowest conditions are December and November, very closely followed by January, February, March. So winter is kind of tough. But after April, things are really nice until you get to September, October. Summertime is great flying here in Grand Forks. And same trend in Fargo. You can see highest frequency of low conditions in December and November, and also January and February and March, but summers are great. Okay, that's all I have for this PowerPoint, and we'll talk about how to fly IFR conditions, how to flight plan in the next video.